right, day 2, solving one-step inequalities continued, 3.4b. So we're going to keep solving inequalities, but we're going to review some of our important properties as well in this lesson. So let's warm up with some review from last time. Solving an inequality that looks like this. So we have 13 plus x less than or equal to 16. So remember, to get rid of the plus 13, you will need to do the inverse of adding 13, which is to subtract 13 from both sides. So you're going to end up with x is less than or equal to 16 minus 13 is going to be 3. When you graph that, then you're going to have a closed circle because it is equal to 3, and then you're going to be going to the left for less than. The inverse of x minus 5 less than or equal to negative 8 would be plus 5. So we're going to use adding 5 to both sides to solve for x. Get x by itself here is going to be less than or equal to negative 8 plus 5. Negative 8 plus 5 will be negative 3. So x is going to be less than or equal to negative 3. So we're going to have negative, I'm going to start at negative 5 and then count my way back. Negative 5, negative 4, negative 3, negative 2, negative 1, 0. This would be another closed circle because it's equal to and then to the left. And then review compound inequality. So this means that negative 2 is less than or equal to x, and x is less than or equal to 10. You could also read it from the inside out. Negative 2 is less than or equal to x is the same thing as x is greater than or equal to negative 2. So if you read it from the inside out, x is greater than or equal to negative 2 and x is less than or equal to 10. Basically, x is between negative 2 and 10. So we could graph this on the number line. If we started at negative 4, negative 2, 0, 2, 4, 6, 8, 10, 12. We're equal to both, so closed circles at negative 2 and a closed circle at 10, and x is less than negative 2, so that means x would be bigger than negative 2, and x would be less than 10, so this way. There we go. Sorry for the interruptions here. One solution to the inequality would be 4. Any number between negative 2 and 10, including negative 2 and 10, would be included in our solution. All right, so just a little review with dividing and multiplying with integers. Remember, when you divide by a positive number, you keep the same inequality sign. So like in this example, we're dividing by positive 6. 6x was less than or equal to 18, which gives us x is less than or equal to 3. We keep the sign the same. When we multiply by a positive, x divided by 5 is greater than 4. So to get rid of divided by 5, we multiply by 5. That gets rid of our 5's here, and we get x. And 4 times 5 is 20. Notice we keep the inequality sign the same when we multiply by a 5. But when we multiply or divide by a negative, we must flip the sign. So if we had something like this, where it was negative 2 times x is greater than or equal to 6, and we have to divide by negative 2 on both sides, then we get x, and then we get less than or equal to negative 3. So when we divide by a negative or multiply by a negative, you have to switch the sign, so flipping it. So our first problem here is 2m less than or equal to 12. Remember, that means 2 times m is less than or equal to 12. And then the inverse of multiplying by 2 is to divide by 2. So then we get 2 divided by 2 is 1, so we're left with just m. We divided by positive 2, so we do not flip the sign, so it stays less than or equal to. Then 12 divided by 2 is 6. So then we get 4, 5, 6, 7, 8. M is less than or equal to 6, so including 6, and then to the left, less than or equal to 6. All right, our next one said 15 is less than or equal to negative 3x. So 15 is less than or equal to negative 3 times x. The inverse of multiplying by negative 3 would be to divide by negative 3. And we're going to do that to both sides. So 15 divided by negative 3, a positive divided by a negative gives us a negative answer. And 15 divided by 3 is 5. Since we divided by a negative, we have to reverse our inequality sign. So instead of less than or equal to, we make that greater than or equal to. Then negative 3 divided by negative 3 is 1, and we get x. And then one more thing, since this one, our variable is on the right side, we need to flip-flop our inequality. We need to flip it around. So I'm going to do x and negative 5. And if I flip that around, then I also need to flip my inequality. So I have negative 5 is greater than or equal to x, which is the same thing as x is less than or equal to negative 5. Now it's set up nicely to graph it. Negative 5, I'm going to start with negative 7, and then count up towards 0. And less than or equal to would be a closed circle, and then we would be going to the left. Negative 6, negative 7 are less than negative 5. All right. Our next one, when we have a fraction problem like this says negative x divided by 4 is greater than or equal to 12. That's the same thing as x divided by negative 4. So when you have a negative fraction, the negative can go with the top or the bottom. When you're having an equation like this, you want to put the negative with the value, with the number, the constant. So then if it's divide by 4, the inverse of dividing by 4 would be to multiply by 4. So I'm going to multiply both sides of this equation, and sometimes we do this, but we're going to multiply both sides by negative 4, or negative 4 over 1, because then negative 4 divided by negative 4 is 1, and I'm just left with x divided by 1. So on this side, I just get x, and then 12 divided by negative 4, 12 times 2 is 24, times 2 again is 48, and then it is positive times a negative, so my answer would be negative. Since I divided by a negative, I need to flip my inequality. So now instead of greater than, it's going to be less than or equal to. So whenever we multiply or divide by a negative, we flip our inequality sign. And x is less than or equal to negative 48, so I'm going to start with maybe negative 50, then negative 49. We'd count backwards here, negative 48, negative 47. We would be getting less negative towards 0 to the right. This would be a closed circle at negative 48 because we're equal to, and the values that are less than would be to the left. This one we have 2/3 times x is greater than or equal to 9. So if we have 2/3 times x is greater than or equal to 9, we can get rid of a fraction by multiplying by its reciprocal. So 2/3 we can multiply by 3 over 2, and then whatever we do to the left we have to do to the right as well. So 3 over 2 again. Here we're going to get top times top, so 6, over bottom times bottom, 6x. We didn't multiply by a negative, so we're going to keep our inequality sign greater than or equal to. To multiply a whole number by a fraction, we put the whole number over 1. Then we multiply across the top. 9 times 3 is 27, and then 1 times 2 is 2. Then we can simplify these fractions. 6 divided by 6 is 1, so we just get x greater than or equal to. 27 divided by 2 is going to give me a decimal. 27 divided by 2 is equal to 13.5. So I'm going to put 13.5 here. So when we graph this, if I'm counting by ones, like 10, 11, 12, 13, 14, 15, 13.5 is going to be in the middle of 13 and 14, so halfway between. And then we have a closed circle at 13.5. I must really like the closed circles because I feel like all of my examples are closed circles. And this time it's greater than though, so we're going to be going to the right with our graph. All right, we're going to do one more. This time we have a negative 2/5 x greater than or equal to negative 8. So when we have a negative fraction, we can apply this negative either to the top, or we can or to the bottom. Sorry.
After school activity are asked to leave the building for the remainder of the day. Students and staff that are, students that are not participating in an activity after school schedule.
Okay, so I'm going to apply this to negative 2. I'm going to multiply by the reciprocal again. So 5 over negative 2 times 5 over negative 2. Then I'm going to multiply this out. I'm going to get 5 times negative 2 is going to be negative 10. Negative 2 times 5 will be negative 10x. Since I multiplied by a negative this time, I will have to change this from greater than to less than or equal to. Then I'm going to put negative 8 over 1, multiply across the top. Negative 8 times 5 will be negative 40. 2 times negative 1 will be negative 2. Then simplify. A negative 10 divided by a negative 10 is a 1, positive 1. Negative divided by negative is positive. Less than or equal to 40 divided by 2 is 20, and negative divided by negative is positive. My final answer here will be x less than or equal to 20. I apologize for the interruptions on the intercom here, but 0, 10, 20, 30. We have a closed circle one more time, and we're going to the left. All right, thanks for watching.